9.3, Arithmetic and Geometric Series. The nice thing about today's lesson is that the formulas are both provided for you on the reference sheet, as highlighted here. It's the sum of the finite arithmetic series and sum of the finite geometric series. So this table sums it up for you. In lesson 9.1, we learned how to find the nth term of a sequence. This formula is for arithmetic, this formula is for geometric, and you have to memorize those. Then today's lesson, 9.3, we're learning to find the sum of the first n terms of the series. And we remember that series is the summation of the first n terms. So here's the formula. Arithmetic requires you to know the first term and the last term of the sequence. First term and the last term of the sequence. And most of the time they don't give you what the last term is, so you have to figure it out. And we know how to do that because we know how to use this formula. And whatever the last term is, if it's the 15th term, we just plug 15 in here, find the common difference, and we get the last term. Put the last term in here, first term in here, the number of terms that we're adding up together, and you get your sum. Now the geometric series formula is actually easier because you only need to know the first term and the common ratio. Example 1. Find the sum of the first 7 terms of the series 4 minus 16 plus 64 minus 256, ... As you see, you always must identify whether it's arithmetic or geometric first. Now we can see that this is switching from positive to negative. The positive to negative must be geometric, and we're actually multiplying by -4 each time to get to the next term. So we know that our common ratio is -4, and we're going to add the first 7 terms together, so n equals 7. So we take our formula that's provided on the reference sheet, plug all the values in very carefully, and then even more carefully put them into the calculator. So as you can see, use those parentheses. Anytime you have parentheses, anytime you have a negative number, put parentheses around it, especially when you're bringing it to a power. And as you can see, the final answer is 13,108. Number 2, find the sum of the first 12 terms of the sequence -9, -5, -1, 3, ... And as you can see, this is arithmetic because we are actually increasing by 4, so the common difference is 4. N is 12, and the first term, a sub 1, is -9. Now because we want to find the sum of the first 12, we need to find what that 12th term is. So we're going to use that memorized formula to find the 12th term. So this right here, we're going to plug in -9, it's the first term, 12 goes in for n, and 4 is the common difference. Use your order of operations, and the 12th term is 35. Now that we have the first term and the last term, we can use the formula that's provided on the reference sheet. It's called that series formula. And we plug everything in, 12 times -9 plus 35, all divided by 2. You end up with 12 times 26 divided by 2. The total is 156. Number 3, a theater has 20 rows. There are 10 seats in the first row. The number of seats increased by 2 for each succeeding row. Find the total number of seats. So if the seats increase by 2 for each row, we know that this is arithmetic. There are 20 rows, so n equals 20. The first row has 10, so a sub 1 is 10. And the difference between each row is 2. So the common difference, d, equals 2. So in order to sum all 20 rows, we need to find how many seats are in the 20th row. So once again, we're going to use that memorized formula to find the 20th term. So we'll plug in our values. The first row has 10, 20 goes in for n, and the common difference is 2. 48 seats are in the 20th row. Now that we have the first and the last, we can plug those into this formula, the series formula, and we end up with 20 times parentheses 10 plus 48, all divided by 2. The result is 580 seats in the 20-row theater. Sage and scribe number 1. The sum of the first 8 terms of the series, 3, negative 12, 48, negative 192, is, and you have your multiple choices. Now this is geometric because the common difference, the common ratio is negative 4. We're multiplying by negative 4 each time. The first term is 3, and we're trying to find the sum of the first 8 terms. So n equals 8. So like we said in the notes, the geometric formula for the series is actually easier because you only need to know the common ratio and the first term. So you plug those in, very carefully put these into the calculator, parentheses around negative numbers that are being raised to a power, and the final result is negative 39,321. The answer is 3. Last one. A grocery store clerk arranges oranges in a triangular fashion, starting with 3 in the first row, 6 in the second row, 9 in the third, and continues this pattern until the 16th row. How many total oranges were used in this arrangement? And this is arithmetic, because we're increasing by 3 every time. 16 is the number of rows. The first term is 3. And we're trying to figure out what that 16th term is so we can add them all up in this formula. Because as you can see, we have everything we need for this except for the nth term. So we're going to use this original formula that we memorized, plug in our values, and the 16th row of oranges has 48 oranges in it. So therefore we know that a sub 1 is going to get 3, a sub n, or a sub 16, is going to get 48. N is 16. We plug these in and do the math. Final answer, 408 oranges. Ladies and gentlemen, there's your lesson, series arithmetic geometric.